Hi, welcome to another video. This video is going to be very interesting as we have seen the most important topic of your syllabus, which is mole concept. So this video, we are going to solve the problems from that topic, mole concept. So we are going to take 2018 to 2022 papers, the paper 4, and we're going to see all the problems asked from this small concept, and we're going to solve one by one all the problems. So let's do this. Video will be very interesting, so let's start. So this is paper 4 and February March series 2018. So we're starting with 2018. Let's see what is our problem. So hold on. Here's our problem. Okay, let's solve it. Saying the students started with 20 centimeter cube of 0.2 mole per decimeter cube sodium chloride solution. Determine the amount of sodium chloride used over here. So here the amount of initial. So let's write down the formula. So concentration equals to mole per decimeter cube. This is what we volume, mole per volume. This is what we have seen the formula. Now the concentration is given 0.2 mole per decimeter cube. Now the mole we don't know, so mole equals to mass divided by molar mass. Decimeter cube means volume, so volume is 20 centimeter cube. Let's put 0.02 decimeter cube. Okay, so now mass equals to 0.2 times 0.02 times MR of sodium chloride. So let's calculate the MR of sodium chloride. Sodium is 23 plus 35.5 is the mass for chlorine. So it will be equals to 58.5. So 0.2 times 0.02 times 58.5. So if you do it in calculator, you're going to get 0.234. So equals to 0.234 gram. Okay, so we got 0.234 gram. Oops, the question said, oh, okay, how many moles? Right. So we need not to calculate the mass. We just need to calculate the mole. So mole equals to concentration into volume in decimeter cube. So concentration is 0.2 times volume is 0.02. So it will be equals to 0.004 mole. Great. So we have calculated one step ahead. No problem in that. The yield of sodium nitrate crystal was 90%. Okay. Calculate the mass of sodium nitrate crystal made. Okay, so let's see the equation. The equation says sodium chloride reacts with silver nitrate to form sodium nitrate. Okay, now from the equation, what I can see, 1 mole of sodium chloride reacts to form 1 mole of sodium nitrate, NaNO3. So the equation is balanced. And okay, now how many moles of sodium chloride we have? 0.04 moles. So 0.004 moles of sodium chloride is going to form 0.004 moles of sodium nitrate. Now the question in the question it is saying the yield is 90%. So if the yield is 90%, so that means 0.004 into 90 divided by 100. So this is the amount of the moles of sodium nitrate formed. So we can do this calculation. So equals to 0.0036 mole. Okay, so we got the mole. Now question is saying mass of sodium nitrate. So mass equals to mole times Na, mole times Mr. So mass equals to mole times Mr. Mr of sodium nitrate, we need to calculate that. So sodium nitrate NaNO3, sodium is 23 plus nitrogen is 14 plus 16 into 3. So if we do this one in calculator, so 23 plus 14 plus 48. 85. 85 is the mass MR for sodium nitrate. So 0.0036 times 85. So this is going to give us the mass. So 0.0036 times 85, 0.306 gram. So 0.306 gram. So this is the amount of sodium nitrate we are going to get. Okay, so this is about 2018 question paper. Let's see 2019. So here is our 2019 paper, and let's find out the mole concept questions which we are going to solve. Okay, so here's our problem. It's a titanium oxide is reacting with carbon to form titanium chloride. Okay, let's do it. Calculate the volume of chlorine gas at room temperature. Okay, we need to find the volume of chlorine gas that reacts with completely 400 gram of titanium oxide using the following steps. Okay, calculate the relative molecular mass MR of TiO2. Very simple, we need to calculate MR, so you can get the AR data, atomic masses data, from the periodic table given. So one titanium has mass 48 and plus 2 oxygen, so 16 into 2. So 48 plus 32, 48 plus 32, it's going to give us 80. So 80 is the MR. Okay, MR of TiO2 is 80. Okay, calculate the number of moles in 400 gram TiO2. So quickly, mole equals to mass divided by MR. So mass is 400 divided by 80. So let's do it. 5. So 5 moles. Okay, determine the number of moles of chlorine that react with 400 gram of TiO2. Wonderful question. So look at the equation. The equation says, again, the stoichiometric calculations. Equation says 1 mole, I'll do it here. 1 mole of TiO2 is reacting with 2 moles of chlorine. Okay, now how many moles of TiO2 we have? 5 moles. So 5 moles of TiO2 is going to react 5 into 2 moles of chlorine. So 10 moles of chlorine. Okay, so moles of chlorine reacted 10. Great. Calculate the volume of chlorine that reacts with 400 gram of TiO2. So again, that video I made for calculation of volume, you can go to the video section and you can see the video how to calculate the volume. So the formula is mole equals to volume divided by 24. So I'll directly write volume equals to mole into 24 decimeter cube. So mole, we got 10 into 24, so 240 decimeter cube. Okay, the chlorine gas is going to form. Very easy, very quickly you can calculate, and all the 4 marks you're going to achieve here. Let's see the next paper. So here is 2020-22 February March paper. Next 2020. Let's find the mole concept question quickly. And yeah, here's a question, mole concept question. Very easy to find. Let's solve it. So here's a reaction given again. Question is saying 3.04 gram of lithium. It's a complex which is forming this product. Calculate the number of moles of this complex formed. MR is given 152 and 3.04 gram. Very simple. So mole equals to mass divided by molar mass. So mass, you have 3.04 gram divided by molar mass is given. You need not to calculate. So 3.04 divided by 152. You're going to get 0.02 mole. 0.02 mole. Okay, deduce the number of lithium fluoride needed. So read the equation. From the equation, 6 moles of lithium fluoride is forming this complex LiPF6. 1 mole of this complex is forming. Now 0.02 moles of
Okay, so here 0.02 moles of this complex is given. So how many moles of lithium chloride we need to do? So do it in a reverse way. 1 mole of this complex LiPF6 is forming 6 mole of forming from 6 mole of lithium chloride. Okay, now 0.02 moles of this complex is going to form from how many moles of lithium chloride? So 6 into 0.02. Okay, so this is the amount we are getting for um, lithium fluoride moles. Now question, so 0.12 moles. So here's the answer: 0.12 moles of lithium fluoride needed. Calculate the mass of lithium fluoride needed. So again, mass equals to mole times mr. So mole is 0.12. mr, we need to calculate the mr for lithium and fluorine. You have to search the periodic table. So mass of lithium is 7 and fluorine is 19. So 7 plus 7 is for lithium plus fluorine is for 19, which you are going to get 26. So 0.12 times 26. So let's do it on the calculator. So 3.12 gram. 3.12 gram. Okay, so this is your answer. So this is from 2020 paper. Let's see for the next year paper.
So this is our 2021 paper, and just check it out. Where is our mole concept question? Yeah, here it is. Okay, so a big question. It's a neutralization reaction question. So here's a titration experiment. 20 centimeter cube of aqueous sodium hydroxide reacts with exactly 25 centimeter cube of 0.1 mole per decimeter cube dilute sulfuric acid. Okay, so circle the name of the type of the reaction. So it's a neutralization reaction, acid and base reaction. Okay, calculate number of moles of dilute sulfuric acid used. So here you have 25 centimeter cube of 0.01, sorry, 0.1 mole per decimeter cube sulfuric acid is used. So in a container, let's say you have 25 ml of 25 ml 0.1 mole per decimeter cube solution is there. So what will be the mole? So concentration equals to mole per volume. So mole equals to concentration into volume. So concentration we got 0.1 mole per decimeter cube. Volume is 25 centimeter cube. We need to convert it into decimeter cube, 0.025 decimeter cube. So multiply this one, it will be 0.0025 mole. 0.0025 mole. Okay, now let's move for the next question. Determine the number of moles of sodium hydroxide which reacts with dilute sulfuric acid. Okay, so you have to find the number of moles of sodium hydroxide. Look from the equation. This equation is very important. From the equation only you will be able to calculate. How you will be able to calculate? So 2 moles, 1 moles of H2SO4 is reacting with 2 moles of NaOH, right? Now how many moles of H2SO4 we are having? 0.0025 mole of H2SO4 is going to react. So 2 into 0.0025 moles of NaOH, sorry, 2 into 0025 moles of NaOH, so will be equals to how much? 0.005. Okay, this is the amount of moles which is reacting with the sulfuric acid. Now calculate the concentration of the aqueous sodium hydroxide solution mole per decimeter cube. So concentration equals to mole divided by volume. Now mole we got 0.05, sorry, 0.005 mole. Now the volume in the question it is given. Let's check. So 20 centimeter cube is aqueous sodium hydroxide reacting. So divide by 20 centimeter cube minus 0.02 centimeter cube. Okay, let's put it in the calculator. 0.005 divided by 0.02. You're getting 0.25 mole per decimeter cube. 0.25 mole per decimeter cube. Now calculate the concentration of the aqueous solution of sodium hydroxide in gram per decimeter cube. It's a beautiful question. So our concentration here, it is mole per decimeter cube, right? So 0.25, this is our mole per volume, is equals to 0.25 mole per. Now here it is mole per decimeter cube. Now question saying gram per decimeter cube. So mole, we got mole is 0.05. Mole means mass divided by molar mass, right? MR divided by volume or 0.02. So here mole equals to, I can write mole equals to mass equals to mole times MR divided by 0.02, right? So mole we got 0.005. MR of sodium hydroxide is 40. You can calculate like 23 plus 16 plus 1, right? 16 is for oxygen, 1 for hydrogen, 23 for sodium. So 40. So this is the amount divided by 0.02. So let's calculate. So 0.005 times 40 divided by 0.02. We're getting 10 gram per decimeter cube, right? So this is how we can calculate. Here we just convert this mole in terms of mass, right? Okay, let's see for the next year question. So here's our 2022 paper, and let's find out the mole concept question quickly. Yeah, here's a mole concept question. The question says,
The question says, determine the volume of carbon dioxide gas given off when magnesium carbonate is added to 25 centimeter cube of 0.4 mole per decimeter cube ACl at room temperature. Okay, calculate the number of moles of ACl in 25 centimeter cube, 0.4 mole per decimeter cube of acid. So very simple. Once again, the number of moles. So the same questions. Concentration equals to mole per volume. So mole equals to concentration times volume. So concentration we have 0.4 mole per decimeter cube. Volume is 0.025. So 0.4 times 0.4 equals to 0.01 moles. Okay, determine the number of moles of carbon dioxide gas given up. You have to look at the equation that 2 moles of ACl is giving 1 moles of carbon dioxide. So we can solve like 2 moles of ACl can give 1 mole of carbon dioxide. So now we have 0.1 mole, 0.01 moles of HCl is going to form 0.01 divided by 2. So this is going to give us the carbon dioxide will be 0.005, 0.005 moles. So we got the moles of carbon dioxide. Now calculate the volume of carbon dioxide given off in centimeter cube. So now volume of the carbon dioxide equals to mole times 24. We'll get in decimeter cube. So we can multiply 1000 over here in order to find in centimeter cube. So 0.005 times 24,000. So 24,000 if we multiply, we are going to get 120 centimeter cube. So 120 is that. Is there any more question? No. Okay, so this was the series from 2018 to 22. All the mole concept papers solved. If you want the more questions, please do contact. Please follow the next screen. Thank you so much for watching. Please do subscribe my channel.